Well, hello again. In this example, you will learn how to create qualitative influence lines for an indeterminate beam. Specifically, we will be looking at this multi-span beam, and we'll be looking at the following quantities. Influence lines for the reaction at B, for the internal shear that is just to the left of point C, and for the positive moment located at point B. This is a very simple approach, and we will start with the reaction at By. This simply requires that at point B, we assume that we take this support and we shift it up by a unit displacement. So we will go ahead and do that here. Shift it up by a unit displacement. We then need to simply sketch qualitatively the deflection for the remaining part of the beam. And the easiest way to handle that is going to be to come back here and note that the support at A means that there can be no translation, no up and down movement at point A. The support at C tells me the same type of thing. At this stage, we simply need to connect those dots using a curve. And that is our qualitative influence line. Qualitative meaning one that doesn't have values, but we have the general shape. And so we can tell the influence of different regions, such as here develops the negative influence line. Here we have a negative influence line, and this is all for the reaction at By. Let's try something a little bit more complex. In this case, we are looking for the influence line just to the left of point C. So I'll denote that as V sub C dash L. So what that requires of us is we are to insert just to the left of point C a shear release. If I'm looking for an influence line for shear, I need to insert a shear release. Recognizing that when I sketch this, I want to sketch it as if I'm applying a positive shear couple, and that's what I've got going here. Now, before I sketch any of the deformed shape, what I want to do is I want to identify what the supports are telling me regarding the deformed shape itself. So, support at A tells me I can't move up or down. Support at B tells me I can't move up or down. And the support at C tells me I can't move up or down. I know that with my shear release, the right side wants to push up, but it can't because it's over the support. The left side wants to move down, so I'm going to go ahead and sketch that as if it moves down, and we will just go through the points of known deflection. Okay, now we have to remember how shear releases work. What a shear release says is that the slope on either side of a shear release has to be the same. So if the slope of my beam just to the left is like that, then the slope just to the right of point C is like that, and I can go ahead and finish sketching in that deflected shape. So we've got another qualitative influence line taken care of. The last influence line we're going to be looking at is for the moment at B, the positive moment. And what that really means is that I'm wanting to impose a positive rotation at point B, and that will then tell me what it is for the positive moment at point B. What this requires is that I insert a moment release at point B, and then I impose a positive rotation. So that positive rotation is just to the left and just to the right of point B. But before I sketch the deflected shapes, let me make sure I know what the support conditions are telling me. Point A says I can't move up or down. Point B says I can't move up or down. That can be a surprise to some people. But the roller says I can't move up or down, so whatever deformed shape I do, I need to make sure that it doesn't move up or down at that location. Same thing at point C. Now it's worthwhile discussion here as we try to make this sketch, recognizing that that is rotating counterclockwise. So when I sketch the deflected shape there, I want to sketch it as if it has rotated counterclockwise. And likewise, this one rotates clockwise, so I want to sketch that beam so that it has rotated clockwise and go through my other point of known displacement. And that concludes the qualitative influence line for the moment at B. So as a really quick review, come back here. In order to get the influence line for the reaction at B, we imposed a positive unit displacement at point B, and then we connected the dots going through all known supports. In order to get the influence line for shear, we had to insert a shear release, but in this particular case, one of our shear releases, or the edge of one of our shear releases, was over the support at C, so all the motion or the displacement had to occur on the left side of that shear release, and that's exactly what we saw in this particular case. And lastly, we needed to make sure that we identified and honored all the support conditions at point A, B, and C. There is a tendency for people to want to draw that influence line as if it comes up here, and that simply is not going to be the case. It can't move up and down because of the support at point B. That concludes this example. As always, it's a beautiful day for studying structures.